You people better appreciate me taking the vise off. You have no idea how well indicated that thing was. Hello Internet, my name is Quinn and this is Blondihacks. This is Mill Skills, a series of quick videos on learning to use your vertical mill. This is part 8, basic work holding and fixturing. Let's go. Why is it that I start so many of these mill skills videos on the lathe? Well, because lathes are awesome, duh. But there's another reason in this case. Why is it that work holding is such a complicated and often argued about topic on the mill, but on the lathe, not so much? There's basically two reasons for that. First, honestly, the four-jaw chuck is just so incredibly versatile that there's very few lathe work holding problems for which the four-jaw does not have some solution hiding in it somewhere. So this is like 80% of fixturing solutions on the lathe. Maybe another 20% are the collet chuck, and the last 10% is the faceplate. Now, much of what we're going to talk about on the mill applies to the faceplate as well. And in fact, this shift of work holding challenges to the mill is largely a product of the availability of inexpensive and decent quality hobbyist vertical mills. If you look at the old model engineering books, they are full of insane looking faceplate setups and wild fixturing that you wouldn't necessarily want to be standing near when it spins up. But that's because back then the lathe was really the only machine that the hobbyist had access to, so all of those operations that we now do on the mill all had to be done on the faceplate. And there pretty much always is a way to do it on the faceplate, but it's tricky to set up and often hair-raising. So if you have a mill, it is a lot easier to do most of these things. So we are mill-bound with the rest of this conversation. Now obviously every work-holding conversation on the mill is going to start with the vise. The vise is the king of work-holding. But do you really know why that is? Have you ever thought about what the superpowers of the vise are that make it the obvious choice and why there's a vise bolted to the center of 99.9% of the mills in the world? The advantages are twofold. First is permanent, repeatable access to a reference surface. This unassuming little fellow is the true superpower of the vise, the fixed jaw. This gives us a reference surface to the machine and by extension the spindle. Because this surface is precision ground and very flat, as are all of the interfaces between this surface and the table all the way down, everything's precise and nothing can move. We know that this is a constant relative reference to the spindle, and that makes it immensely valuable. So a way to think about the fixed jaw is that it's like a quick draw fixture plate that you don't have to set up and it's always there when you need it. There's one more, I think, very underappreciated superpower of the vise. Do you see it? It's one of those things where it's obvious once someone points it out, but until the superpower is gone, you don't appreciate it. The vise gives you complete access to the entire top surface of the part. And you don't appreciate that until you try to set something up without the vise. If you've got a part that's too big to work on in the vise, so you need to clamp it directly to the mill table, you will suddenly discover how valuable it is that the vise exposes the entire top surface of things. Because this allows us to create any features that we want on top, as well as giving us access to however much of the sides that we need for three-dimensional features on the top. Don't underestimate the power of that. Now let's talk about round things. How do we work with round things in the mill? Well, let's start with the vise again, because again, this is the quickest and easiest way to do most mill setups. If you're new to machining, you might think, well, I can just clamp my round stock in the vise like that. Good to go, right? Not really. An important concept in machine shop work is points of constraint when clamping. For round things, you always want 3 points of constraint in the direction of clamping. And that's the problem with doing something like this. You've got this point here, and the clamping is coming from over here, so you've got 2 points of clamping force. Now there's a third point of contact down here, but this is not in the direction of clamping force. So you're clamping across the round piece. And that's not enough to keep this piece properly aligned in all 3 dimensions. And it's also not a very good grip on that part, so it's likely to move. We need to create a third point of contact. And we have a very special machinist tool for doing that. The V-block. This might seem like no big deal, But what just happened here is actually magical, because what we've done is we've created 1, 2, 3 points of contact in the direction of clamping. So now this part is precisely and repeatably held in 3 dimensions and very securely. This won't move, and it'll give us perfect parts every time. But like everything in machining, there are trade-offs. The V-blocks come with a pretty heavy price. As you can see, we've lost a lot of access to the material. We don't have very good access from the top, and it's taking up a lot of space in the vise, so for larger stock we might run out of jaw room. Lots of compromises being made here. To work around some of these issues, you can buy smaller V-blocks, or most V-blocks will have 2 sizes of V on them, so we can switch over to the smaller one here. This, as you can see, gives us much better access to the surfaces of the part. However, on this particular vise, which is a small vise, now you can see we're actually missing the top of the jaw here, so this can't clamp securely. So in a situation like this, we can put a tall parallel in there. So V-blocks are great because they're very flexible. They work on virtually any diameter of round part, but they are a stiff compromise on access. What other options do we have for holding round stock in the vise? Well, there's one more biggie, and it's my personal favorite, the Callit Block. This might be one of my favorite tools in the machine shop. So as you can see, I can now hold my round stock in there, and something isn't right here. Hold on, let me check the directions. So as I was saying, the great thing about the Callit Block is that it holds collets. Now, of course, you wouldn't just put the stock in here by itself. That would be silly. I don't know who would ever do that. No, what you do is you put your collet in the Callit Block, and then you can slide your stock into your collet. The Callit Block has all kinds of superpowers. In addition to being able to hold round things, it's very easy to set up in the vise, and it's just covered in precision surfaces. So that means you can do all kinds of creative, repeatable work setups with it. For example, if you take care to line up the front edge of the Callit Block with the edge of your vise jaw, this position on the x-axis is now super repeatable. You can take this out, you can go do some other operation on it, bring it back in. As long as you haven't removed it from the Callit Block, you can put it back in the mill, line it up with that front edge, and trust that it's exactly where it was when you took it out. If you do need to take it out of the collet, maybe to do an operation on the lathe, or if you're doing multiple parts, this is a 5C collet, which supports the use of a collet stop in the back, and that allows you to repeat the position of the stock in the collet. And so now I can take this out, do something to it, make a new part, whatever, come back in, put stock in again, and again it's going to land in exactly the same place. So there's lots of different ways that Callit blocks are repeatable. And everybody's favorite feature of the Callit block is that they are also an indexing solution. Because again, everything is precision ground here, I can rotate this block, again, line it up with the front edge of my fixed jaw, and I'm in the exact same X position. I can do an operation here, and I've indexed perfectly 90 degrees. So if you need to mill a square feature on the end of a piece of round stock like this, or maybe you're doing features that are 180 degrees opposed on the round stock, something like wrench flats, again, Callit block has you covered. And if that's not cool enough, you can still take these same collets and put them in a hexagonal Callit block. And now you can do 60 and 120 degree features all day long. You can do 3-pointed features, you can create hex profiles for bolt heads, all sorts of things. And the other secret lesson hiding in the Callit block is don't be afraid to think outboard of the vise. You know, it's easy to think about doing all your work up here because again, that is where the vise really shines. But the vise is also great for holding things in such a way that you can work with them outboard. When you start working outboard of the vise though, now you really got to start thinking about rigidity. It's not much of a concern when you're working in the vise. Everything in here is always going to be rigid. Out here, not so much. So if you're going to be machining features all the way out here, think about where your machining forces are going. If you're drilling, you got a lot of force going straight down. If you're milling, you got a lot of lateral vibration forces. So you have to provide support in whatever dimension you're going to need for the operation, preferably all dimensions. The most basic form of support out here is the humble machinist jack. Sort of ironic, I think, that these are a common beginner lathe project, but these are virtually useless on the lathe. You really only need them on the mill, but on the mill, they are essential. So I can just stick a machinist jack under there, and that's helping quite a bit. Like if I'm drilling straight down, let's say, that's likely all the support that is needed here. However, for any kind of milling operation, this is probably not going to be enough because there's nothing preventing the part from lifting. And remember that end mills do create lifting forces because of the angle of the flutes. And there's nothing preventing lateral vibration here, which is also going to happen from milling forces. You get a lot of force this way and that way when you are cutting. There's a simple addition we can make to this setup though to solve a lot of these problems. Bring in our friend the strap clamp set. Just the simple act of adding a strap clamp to the top of this setup, and this is clamping down on our machinist jack, so make sure that the machinist jack is set up properly so it's lightly touching the bottom of the work so that when we clamp it with the strap clamp you don't deflect the work downward. And you can always check that with an indicator if you need to be really sure. But with this setup we can add a lot of friction to the top of this part and a lot of vertical clamping force. And this is generally going to be enough for any kind of milling or anything that you need to do on this part with all of this stick out. Now once again, we're full of compromises here, right? The strap clamp takes up work on the top surface of the part, so you might have to leave extra stock. If you need to do features all the way down the length of the part, you need to leave something to clamp onto. And then you can create clearance issues with the spindle around the top surface of this clamp. This is a problem much more than you might realize when you're starting out. These strap clamps are seemingly always in the way. Now, things to watch for when using strap clamp setups on hobby mills which have small tables. Think about where the forces are going on this clamp. You've got forces in here, and back here. All three of those points need to be well supported. That means this point back here, you draw a straight line down all of these blocks. It needs to land on your table and not off the edge of your table, which is easy to do because the table is small. If you start clamping on this now and this is off the edge of the table, then this is all going to kick up and it's not going to be a secure clamp. Similarly, on this end, you got to have a straight line down from the clamp through the work into the jack. If any of these are offset, something's going to slip or roll or slide. Now this center point, you don't have to worry about support because it's going into a T-nut, of course, but you do have to think about where this is positioned. You want it, whenever possible, to be closer to the front of the clamp than it is to the back, because this back here is your fulcrum. So this is a lever, and you want it to have the most mechanical advantage possible on the part that you're trying to clamp. If this bolt is further back, most of the downward clamping force is actually going into the fulcrum and not into the nose of the clamp. So it's proportional, right? If you're 30% closer to this side, then 30% more of the force is going into this point than that point. That's high and mighty to say, but very frequently you don't have that luxury because you need the reach. So in a pinch, you can have this bolt further back here, but just know that it isn't going to be clamping nearly as well up here when you do that. And lastly, make sure that the strap itself is horizontal or pointed slightly downward in the direction that you're clamping. You never want this strap pointed uphill. That creates all kinds of problems. First of all, the point of contact on the work will not be on the end of the clamp. It'll be in some mysterious place behind the end of the clamp. Second, it's not going to be a very secure clamp. And third, it's going to tend to push the work away from the clamp. So always make sure that this strap is level, or if you can't get it exactly level, point it a little bit downhill towards the work. There is one more option that you don't see a whole lot, but in certain situations it's just the ticket, and that's the tailstock. Yes, you can get tailstocks for milling machines. Now I can hear you furiously typing your angry comments. People argue about what this should be called. When used on a mill or a grinder, people often say this should be properly called a footstock, but Phase 2 is happy calling it a tailstock, so let's all take a deep breath and take it down a notch, okay? Right away you can see the power of this. Just like on the lathe, the stock is extremely well supported, but we have full access to it. This is a really cool trick. Now, you need a lot of things to come together in order to do this. First of all, the stock has to be lined up with a T-slot, which doesn't tend to just happen. So I've got some packing in here. Another way to do that is to mount the footstock on a fixture plate so that you can move it laterally a little bit. And you'll need to, of course, indicate the stock and get everything perfectly lined up, which is, somewhat labor intensive. So this is going to be only useful in really emergency or special situations. And you can see I've just got it mocked up here sitting on some parallels, but you will also need some way to get the tailstock to the right height. This tailstock is height adjustable, as you can see here, but there isn't quite enough adjustment to reach as high as this stock here is. But again, you can make some kind of a fixture plate or otherwise put packing under the footstock there to get it to the right height. So there's a lot of moving parts here, and so this would be very fussy to set up, but once again, you know, for a certain operation, this might save your bacon one day. Well, this has been all well and good, but one of the first important lessons that a beginner needs to learn on the vertical mill is to think outside the vise. It's time to learn to survive without this magic piece of equipment on here, so let's get rid of it. The most common reason to start working directly on the table is that the piece is very large and won't fit in the vise, but it's also common if you've got things that are really odd shape and there's no good way to hold it in the vise. The table is more work to fixture on, but is ultimately more flexible. Of course, the most basic way to fixture anything to the table is going to be using the T-slots. And the most basic form of T-slot fixturing is our friend, the strap clamps again. All the same rules apply that we talked about before. You want the strap either level or pointed slightly downhill. You want the bolt closer to the work if you can get it. And of course you want multiple strap clamps on here in this case. I wouldn't want to mill it with just one on here like this. But right away you see the big problem with working directly on the table, right? Your opposite clamping surface is always the table, and so your clamping basically always has to come from above, which means you never have total access to the top surface of the work. Now you appreciate what a magic device the vise is. Magic vice? Device? The magic the vice device? It's magic. You get it. So a lot of fixturing jobs on the table are going to involve some sort of working around the problem that you don't have clear access to the top surface. Now there are lots of techniques for working around the situation. Either you can work in sections on the top, or often you just don't need access to the entire top surface, or we can use fixturing methods other than strap clamps. So what if we had a way to clamp the material from the sides, just like the vise does? And there are in fact some ways to do that. One way are two-piece vices, which you may have seen, where there's literally a fixed jaw that you bolt to the table, and then a movable jaw that you bolt on the opposite side of the part and has some adjustment in it, so that you can clamp on the ends of the part, just like a vise. Another option is some sort of sideways working clamp. Now there are a million designs for these. Here's one example here that I designed, and there's a video on my channel of me making these. And if you'd like drawings for these guys, you can find them on my Patreon. They just screw into T-nuts. And of course, the clamping action is coming from the clamp, so you still need some sort of fixed jaw behind the work that the clamps can push into. In this case, I'm just using some strap clamps bolted down to the table, but there's lots of different ways you can rig up a fixed jaw back there. And then once everything's kind of snugged up, then you can go ahead and tighten it down with these bolts here that then apply clamping pressure behind the flexure elements there on the clamps. Now these particular clamps are providing only sideways motion, so of course we will need to tap it down. This problem of table fixturing while leaving the top exposed is such a substantial problem in CNC that there are a lot of creative solutions targeted at CNC machining for that. So look to CNC clamping systems for inspiration. And I say inspiration because most of them are out of the price range of a hobbyist, but they'll give you ideas for kinds of clamps that you can design and build yourself, like these little guys, which were quite easy to make. And I'm also going to link to a website down in the description by Harold Hall, you know, the famous author who's written many amateur machining handbooks. He has a website that shows a whole bunch of examples of these different styles of side clamps, ones that clamp laterally and cam clamps, and ones that provide downward pressure. Lots of different designs. You can get drawings, I think, from him as well, but just looking at the pictures of how the different ones work, you'll get plenty of inspiration sufficient to design and build your own. But if you're really paying attention, something else might have just occurred to you. Sure, I went ahead and clamped this up, and it's really secure. I can machine that. It's not going anywhere. But how do I know this thing is square? Because remember, that was the big other superpower that the vise was giving us. That fixed jaw was a perfect reference surface to the machine and, by extension, to the spindle. We don't have that here. We're just floating in empty space with this piece of stock clamped down here. And well, the answer is we have to do that ourselves. We have to square it up. Now, if you're going to machine the entire part in this setup, as is the case, for example, often in CNC, where they simply remove everything that doesn't look like an elephant from the stock, then this isn't a big deal. But in the hobby shop, this is likely a second or third operation, and you've got a reference surface that you need to get square in order to make your cuts. So we have to get this square to the table somehow. Now, obviously, you can just use a square on the edge of the table, and that'll get you within 5/1000ths or something, but that's usually not enough for machine shop work. So we have to bring in our friend, maybe frenemy, the indicator. This is basically the same process as you saw earlier in this Mill Skills series for dialing in your vise, but now you have to do it for the stock, and you have to do it every single time you set up stock. So you can see, just very roughly using the square, we got it within 5/1000ths. And of course, this is not a machined surface here, so there's some error there as well. But from here, we would proceed to tap it in and get it square. If you're going to be doing this kind of thing a lot, or if you know you're going to have to remove this part and put it back more than once, then this process is enough of a hassle that it's worth actually setting up a fence back here, basically creating a temporary fixed jaw. There's a super easy way to do that. Just take a nice piece of scrap stock, bolt it to this T-slot back here with a little bit of space under it, put some washers under it so it's not quite touching the table, and then just side mill the side of it. Take maybe 10 thou off of it, just enough to clean it up, all the way down the length. And now, because you've milled it in situ, regardless of how you bolted it down, you know that it's perfectly square to the table and to the spindle. And if for some reason you can't do the milling in situ trick, then you can just take a parallel and bolt it to the table and indicate in that machined edge there, tap it in until that's perfectly square, and then you can trust that anything you push up against that parallel is going to be square as well. But here in the hobby shop, you very quickly learn one thing about the table. The clamping options on it are low resolution. You've got a T-slot way back here, one here, you got one way up here, and all of your strap clamp hardware is big and beefy, and everything's kind of designed with big parts in mind. And we're doing a lot of small work. Enter our next best friend for table work, the Fixture Plate. Now this happens to be a super deluxe one courtesy of Dayton CNC. I will link to them below. Also sold through a little machine shop. Both awesome places for model engineers. And what's great about a fixture plate is not only do you have a very high resolution of clamping options here, you've got alignment pins and lots of holes to clamp on. The plate itself, once squared up to the table, you only have to do that once, can then be trusted. So once I indicate this in, just like you would with a piece of stock sitting on the table, then anything I clamp to this table using these alignment holes, I know is also square. So this saves you a ton of indicating work if you're going to be setting things up and tearing them down a lot on the table directly. So this particular kit came with these beautiful ground alignment pins, and you can place these anywhere on the table, and now you've got yourself a fence that you can set your work up against. And again, once the fixture plate is square, then I know I can push things up against those pins and the work will be square. And don't forget, you can mix and match all of these tools. So if those pins aren't in a very convenient place for you, you can put down a parallel and you can shift the work a little bit. And now again, we're up against those pins and we're up against two precision ground parallel surfaces. That's why they call them parallels. And so we can trust that we're square. And if you need to move it a little bit different distance, put in a different sized parallel. Or if you need to do multiple operations on something like a rough casting, you can fixture your casting to the fixture plate once, dial in some reference on the casting, leave it there for multiple operations, take it on and off the machine, and every time you put it back on the mill, you know you can indicate in the same reference surface and your casting will end up exactly where it was. And then if you're going to be working on a fixture plate, you want to invest in a small set of strap clamps that are appropriately scaled for the fixture plate and for the size of work that you're doing. You know, we all have these giant strap clamp sets because they're cheap like borscht on Amazon, and you definitely want to buy a set like these for your mill. But if you're doing hobby work and model engineering type of things, you're going to want a nice small set that is scaled to the size of work that you're doing, because then you can clamp things and not take over the entire surface of your part with your strap clamp. But fixture plates don't just go horizontally, they also go vertically. This is a 90-degree angle plate, and this will solve all manner of fixturing problems that can't be solved any other way. Common use case is you might have an irregular shaped part like a casting. You need to mill something on the top surface of it, and there's no way to hold it from below, but there might be something on the sides that you can bolt onto or otherwise grip, and that's where the angle plate comes in. These come in all sorts of different sizes. I find actually having a really little one like this is really helpful on hobby machines, because these big ones can often limit the table travel or the spindle or quill travel depending on how you have them set up. There are of course angle adjustable versions of fixture plates as well. I don't own any of those, they're a little spendy, but if you need to do a lot of precise angle milling, that could be a good investment. And don't forget to mix and match all of your fixturing pieces. So maybe you want to bolt a 1-2-3 block to an angle plate. Now you got a nice little shelf here that might be just the thing for a particular operation. Or maybe you've got a V-block for something round and you can clamp this to an angle plate. Now you've got a perfect setup for a particular operation that way. Some of these look like they might never be useful, but file all this kind of stuff away in the back of your head, because someday it's going to be just the ticket to get you out of a tight spot on a fixturing setup. But the fixture plate is as much a state of mind as it is an actual tool. When you think about how a fixture plate works, you can then apply that laterally to other things in your shop that can serve a similar role. So you've seen me do this a lot on my channel, clamp something to a 1-2-3 block and then fixture the 1-2-3 block. So the 1-2-3 block in this case is acting as a tiny fixture plate for the work. And this is actually super effective for very small parts like, on model engineering projects, because these 1-2-3 blocks of course have threaded holes in them, at least this cheap brand from Amazon that we all buy do. And so those are useful for clamping work to, or you can through bolt through the other holes, or you can bolt in from the sides and then clamp through from the top to secure your part. You can also secure your part on there and then clamp the whole block in a vise. Lots and lots of different ways to use this block. Remember our friend the V-block? Well, the V-block is also a fixture plate. If you get yourself a set of these are U-clamps. So we can put round work in here and then clamp it down with these clamps. And now this V-block is acting as a fixture block. Once again, we've got precision ground surfaces that we can use to indicate or square up. And then once this V-block is squared to the table, if we're doing a lot of operations on round parts, again, this setup is repeatable. The block is going to keep subsequent parts aligned, just like a vise would. So look around your machine shop. All of these types of blocks and things that you have lying around are all potentially fixture plates. The vise is also a state of mind. Look at other vise-like things in your toolbox and see how they can be used for fixturing. This is the humble toolmaker's clamp. We all have these. Maybe you've made a set. I made this set here. You saw me do this on my channel earlier. Drawings for this are also available. Now, because a toolmaker's clamp is machined and perfectly square on all sides, you can clamp a small part in one of these and then clamp it to the table. And now it's acting like a little tiny vise. And once again, you can mix and match. So you can bolt a toolmaker's clamp to a 1-2-3 block and hold a part out here in a tiny little vise. There's one kind of second tier tool that I want to talk about, and that's the rotary table. There's a certain category of tools in this world that you need very, very rarely, but when you do need it, nothing else will work. And I think the rotary table falls into that category. It may sit in your drawer for 8 months out of the year, but that one day you need it, boy, are you ever glad you have it. Now, I should say that if you don't have a DRO, I think the value of the rotary table goes up a lot, because one place it really excels is bolt circles. It makes those very easy to do, which, the DRO can also do for you. You could easily do a whole, frankly, video series on rotary tables. There are a lot of cool things that they can do, but that's out of scope here. This video is about basic work holding and fixturing, and to that end, in this orientation, the rotary table is really just a fixture plate, like we've already talked about, with, this one weird trick that it can do. So since this is a work holding fixturing video, I want to talk about the rotary table in this orientation. As soon as you turn it vertically, and not all rotary tables can do this little stunt, make sure you've got a machined surface there on the bottom, but once you set it up vertically, now it becomes a very interesting set of work holding tools. First of all, of course, it acts as just a basic 90-degree fixture plate, but now that rotation feature gets a whole lot more interesting, because when you're sitting flat, there's lots of ways to rotate parts and fixture them. Vertically, however, rotation is a lot trickier. So this becomes very interesting if you need to do vertical and angled milling operations. And then lots of rotary tables will have a center in them of some sort. In this case, I've got a Morse taper 2, so I can put my lathe tailstock tooling in there. And now I've got a center for holding round parts in lots of interesting ways. But of course, if you're going to use a center on this end, you need a way to hold the stock firm at the other end. So it would be more typical to either fixture the work to the T-slots here or mount a chuck on it. And lots of people do that. If you're going to buy a rotary table, I think getting a chuck that's a good fit for that table is a really good idea, because as soon as you do that, now you've really got a full-fledged dividing head, especially if your rotary table has the option to add dividing plates, which lots of them do. And the real superpower of putting a chuck on here is that now we can bring our friend the footstock back in, and now we can hold work up here in a chuck just like on the lathe, and we've got a tailstock footstock just like in the lathe. So this is a very powerful way to work with round parts, or honestly any part that has a center drilled into it, which doesn't have to be a round part. But now you've got a really powerful way to work with stock, holding it between centers or holding it by a center, and the ability to rotate it and work on it in lots of different orientations like this in the mill is really powerful. And last but not least, don't be afraid to make custom fixtures for the part at hand. Oftentimes if something is really difficult to hold, the easiest thing to do is just to mill out a special pocket or a special shape designed specifically to hold that part. Now this is a no-brainer if you're going to be doing a lot of a particular part or a particular operation, but even if you're only going to be doing one, this is often worthwhile just for the precision that it gives you in controlling the setup. And when it's done, you have art. There are as many ways to fixture work on the mill as there are cranky machinists, so this is just a brief overview, but I hope as a beginner it gives you a few rough tools that you can be thinking along the lines of when you're thinking about your order of operations and how to fixture a part. It does take a long time to set all that stuff up, so don't feel like you're doing it wrong if you're spending most of your time fiddling with strap clamps and dialing in, fence parts and so forth. So I hope you found something in here helpful. As always, thank you very much for watching, and if you like these videos, maybe throw me a little love on Patreon, and there's a link down in the description and on the card here at the end of the video. And I will see you next time.